Right, so in this basically short program, we're going to show a simple illustration of Omron. This is the CX programmer. We're going to do the simulation right quick. Now, before you do a simulation, you have to basically make sure you come up here and compile and everything. There is no errors. But I want to show you real quick that this does work. We're going to force it on. Then you can see that's on, and it turns on the output, right? Now, we'll cut the simulation off. We don't have to run it, and we want to go ahead and throw in like a latch bit, right? So we come in here and put that in here. Well, it needs to be down below, and we're going to basically put the output we used down here, and that's the motor coil, okay? And then we want to have similar to like a seal-in circuit, if you would. What we're going to do is we're going to have like down here, we'll have a seal-in circuit, so you can like seal it in and unseal it if you want. And for this matter, we'll do, this would be like 0.01. So basically the second we're going to use this next one, we'll just call this I don't know, we'll call this stop. Call this stop PB, and that way you know, right? So we can change that too. We can change this. Let's see, go to edit, and then you can address that differently if you want to. They got a stop bit, you got a motor coil. We can exit out. We can test this logic by turning on the simulation again. Again, I've already tested to make sure everything was good, so I don't have to compile. So I want to go ahead and force it. I can force this on. Okay, so if I take the force off, right, you can see the logic still it's sealed in right here. So the motor coil is still on until somebody presses the stop button, right? So if I hit the push the stop button, then it kind of turns off. Now, if you notice, we use two different contacts here. One's are normally open, one's are normally closed, and that's in particular, that's a normal like seal-in circuit type situation. So that's what I wanted to kind of show in this situation. And basically, again, this is using an Omron, but the actual processor that we're using, and I'll show you this real quick. It's named Practice. I just threw in a name, Practice. The CP1E is basically a CP, but it's basically your processor, but it's a general processor. It's not made for motion or nothing like that. It's just made for, you know, standard logic, small math algorithms and stuff like that. It's not made for anything special. And then the E20 is the amount of inputs and stuff like that I have. So just keep in mind. And then we're in section 1 down here, right? So again, when you come down here, you can look, right? You can see that I have no comments, I have nothing like that. But it's very simple right now. You can see that I do have, like, say for instance, the force I can cancel, right? Come over here and cancel all forces if I want to. If I want to toggle or something like that, or if I want to set on, you can see that I set it on and then set it off. So I don't necessarily have to force it, but again, there's just different scenarios where you want to do, right? So if I push the button, let's just say if I set the bit right here for the stop button right here, you can see that it cuts off. And that's, again, that seal-in circuit. So you can easily see how that works. Now, again, this was not a very complex scenario. This was not a very, it was basically introduction, if you would, to basically ladder logic. But again, in a different scenario, not using Rockwell, this is using an Omron platform in the CX programmer. So it's a little bit different. And again, when you save a file, you want to name it whatever you named it right here, and then CX programmer file. You can save it as different things, but the .cxp is what you want to save it as, and that way you have it, right? So, and again, you can kill the simulation by doing this up here. You always want to make sure you can compile, and when you compile, there's no errors down here. and then that way you can easily see. Now about what I'm using right here, you can see that what version it was right there. It's really simple. It's really kind of simple logic. Again, you've seen me do this on Rockwell many different times, but again, I'm just showing a different scenario with a different software to show, ladder logic is ladder logic. It doesn't really matter what software you're using. Specifically with an integration or an integrator, if you would, you're going to need to be very versed in different softwares, like a different processor, a different brand. You're going to have to do different things. So this is sort of why I dabble in different things to keep my tool belt, as much as possible. I have variability, I have flexibility to do whatever I can, right? Whether it be Rockwell, Siemens, Omron, whatever's being used, right? Direct PLC or PLC Direct, whatever the customer wants to use. Omron's pretty cheap, so again, when it comes down to it, they are highly used sometimes. But when it comes down to it too, so is Siemens in the U.S. But Rockwell is primarily in the U.S., but is a little, kind of growing in Europe a little bit too. So with that said, hopefully you kind of learned at least what to do right here, adding a branch, adding a circuitry, showing how to do the simulation right here, showing how to make it active, and then turning it on the CX programmer. With that said, hope you learned a lot from this video. We'll see you guys on the next one.